In this video, we're going to explore the idea of using our knowledge of parent functions and positive or negative coefficients to be able to, even just in a multiple choice sense, be able to identify the graph of a function and sort of figure out which graph represents the function that we're looking at. So this first example, right? Which of the following four graphs most likely represents the graph of f of x equals negative x plus 3 squared plus 4? And then why? Right? So the first thing I'd like you to do is decide which two of these graphs are absolutely horribly wrong. Right? And hopefully you can do that easily. Hopefully you recognize, hey, this is a squared function, and you may not know what to do with the plus 4, you may not know what to do with the plus 3, you may not really know what to do with many of the numbers there, but the reality is there's a squared here. And when you have a squared in a function like this, when we have x squared, we get the x squared type parent function. And so that means that this guy here, totally out. Right? This one here also totally out. In fact, as you're looking at this one up here in the upper right, we sort of have this sense that we know what that graph is. This graph here is going to be some sort of a y equals the absolute value of x type thing. It'll probably be a negative one because it's opening downward. Right? This guy here in the bottom left, this is some sort of square root of x, like some sort of positive square root of x. And there are probably some other numbers that go after it. We don't need to know about that right now. The idea is I know for sure that this graph, this function, will not be represented by either of these. So now, how do I pick between the other two? Well, hopefully you also notice that our original function has a negative coefficient. Because it has a negative coefficient, we know that our graph needs to open downwards. Right? Because of that, this is the most likely of the four candidates to be the correct one. This graph here in the upper left, this must be some sort of a positive x squared graph. And again, there are probably some numbers that are added or subtracted around it, but from the options that we have, the graph in the bottom right is the one that's the most likely match for the function that we were given. So here's one of these that I'd like you guys to try on your own. Which of these four graphs most likely represents the graph of g of x equals the absolute value of x minus 1 minus 2? So first see which ones you can eliminate. After that, see if you can figure out which one really does most likely represent that, and then we'll check that answer. So the two that seem pretty clearly to be out are this one, which seems to be some sort of a negative x squared graph, and then this guy down here, which it turns out is an x cubed graph. What's important for your purposes is it's definitely not an absolute value graph. Right? That leaves us with the two choices on the left, and what we notice is this seems to be a positive absolute value function, and because it's a positive absolute value function, we need an absolute value function that is sort of, opening upward, right? I did have one more interesting question, and I wanted to put this in here because you guys know we're sort of in the habit of asking interesting questions on quizzes and tests, and so this is worth considering, right? What happens if we have two functions and they're both opening the same direction? I can't just rely on, this is a positive absolute value graph, and oh no, these are both positive absolute value graphs. Like, how can you tell which one's the right one? And you might pause the video and think about that for 30 seconds. Like, how could you figure out which one of these is the right graph? Right? I feel like one thing you could do is you could find a point that these two graphs don't have in common and figure out which one of them is a solution to this equation. Now remember, what does it mean to be a solution to an equation? Being a solution means that when you take that point and you evaluate this equation using that point, using those values, it will make the equation true. Right? So for instance, if we take, let's say for instance this point right here, this point negative 1 comma 0, if I input that into this function, it's either going to be true or false. Right? And because that point is not shared by this graph over here, we can use that to determine which one is the correct graph. Right? So again, I'm taking this point negative 1 comma 0, and I'll input that into my equation. The y value is 0 equals the absolute value of x, which isn't going to be x anymore. It's going to be negative 1 minus 2 minus 3. So if I work through this, I'll have 0 equals the absolute value of negative 3 minus 3 Moving on, this will give me 0 equals 3 minus 3. Hey, this was true. Right? Because that was true, we know that this has to be the graph of the function that was given. Right? So if anything, the purpose of this last slide has just been this idea that, remember, all of this business about knowing whether a point, knowing whether a value is a solution to an equation is useful all over the place, and it's going to continue coming back to us. So keep in mind you have that as a tool in identifying these graphs.